Your best eval cases are already hiding in production failures. We'll use Langfuse in Python to capture traces and turn bad runs into repeatable tests. This is the workflow you'll know how to run when we are done, which records a failed trace and promotes it into an eval case. I'm Professor Pi, teaching AI engineering and LLM systems with simple Python. LLMs can surprise you in production. A prompt that was fine yesterday suddenly gives bad advice today. Teams spend hours chasing logs and trying to recreate that elusive bad run. The point here is straightforward. Capture the failing run as structured observability data. Then convert that captured failure into a repeatable test. That turns debugging from guesswork into a repeatable process. Langfuse tracing gives you a clear, queryable record of what happened, why it happened, and who saw it. The goal is a saved trace tied to the original user input, a severity label, and a dataset entry you can replay. That lets you triage the worst errors first and prevent regressions before they reach users. Langfuse fits well because it's built for traceable, queryable LLM run data, which works better than ad hoc logs for this workflow. Quick note: this code is designed to teach the core idea clearly. Library versions and local setups can vary, so check the official docs if your setup behaves differently. Now we'll instrument a tiny helper so Langfuse records each call. This snippet instruments a toy uppercase helper with the Langfuse Python SDK, so every call becomes a trace. It instantiates Langfuse with local credentials and keeps a single client instance handy for later steps in the tutorial. The observe decorator wraps the uppercase failure function, yielding both the uppercase string and the shareable trace URL, returned from the langfuse.getTraceURL method. Invoking the helper shows how little work is needed to push even tiny experiments into Langfuse for inspection. The printed URL confirms Langfuse captured the run and gives engineers an immediate entry point for debugging. Next, we'll wrap the helper call in a reproducible span and attach the original prompt context. This example captures the surrounding context by nesting a Langfuse span around the earlier helper. It seeds the span with a deterministic trace identifier through langfuse.createTraceID and records the user question so the trace stays reproducible. Inside the block, the uppercase failure function returns the answer and trace URL tuple. The code stores the answer on failure case, and failurespan.update records that output while marking the span as error for easy filtering in the Langfuse UI. Those few lines preserve the failed behavior alongside the prompt that triggered it, turning a fleeting incident into structured observability data. The printed identifier shows exactly which trace now contains the error annotations. Now we'll quantify the failure so we can rank which traces to fix first. This code converts the qualitative failure into a measurable signal by creating a Langfuse score and ranking traces. It derives a binary severity value from the mismatch and sends it to Langfuse with langfuse.createScore, attaching the manual severity metric to the offending trace. The same value feeds a tiny in-memory severity values dictionary, so the max call can spotlight whichever trace should be triaged first. The Langfuse getTraceURL method produces a slug engineers can paste directly into the UI without hunting through logs. The printed line highlights which trace currently carries the highest severity, and therefore deserves investigation. Next, we'll add that failure into a persistent dataset so it becomes an eval item. This snippet promotes the captured failure into a reusable Langfuse dataset item. The langfuse.createDataset call defines the eval regressions container, so future experiments have a consistent home. Next, langfuse.createDataset item stores the original user query, the expected remediation, and the source trace identifier, keeping provenance intact for anyone reviewing the dataset. Because the dataset item links back to the trace, evaluators can hop from structured test data to the raw observation in a single click. The printed identifiers confirm the dataset now includes that regression example for repeated evaluations. Finally, we'll replay the saved dataset item against a patched helper to verify the fix. This example replays the new dataset entry against a patched helper to prove the regression is fixed. The patched reply function adds basic intent detection, returning the corrected guidance whenever a config flag prompt appears. Pulling the input and expected output straight from failure item keeps the evaluation grounded in what Langfuse recorded, rather than ad hoc notes. The equality check serves as a lightweight regression test that can precede model or prompt promotions. The printed status reports that the evaluation passed and shows the generated answer. In a real project, this maps directly to a CI step. New model builds can pull the Langfuse dataset and run every preserved regression case. Failure traces stay linked, so engineers always see the exact run that produced the bad output. Recap: this is a workflow that captures failing LLM runs, labels them with severity, and turns them into replayable evals. Use it when production surprises are frequent and you want deterministic regression tests. One caveat: you must design meaningful expected outputs, or you will record noisy tests that give false alarms. Next step: scale the same approach by running your saved dataset against larger candidate pools, and add timing and accuracy checks, so you measure both correctness and latency. If practical AI engineering helps, subscribe and watch the AI engineering videos.